There we go. Well, welcome for what's the episode? 177? I'm just back from vacation, so I know nothing. Um, but I do know about this topic we have this week. Uh, it's about TLS, which is probably the most boring and the most useful thing we've done in a while. um, but if we don't have any news, well, we might have news, but I don't know of any because I just started this morning. Um, but I'll let you, Clément, introduce yourself and walk us through the wonderful TLS.
Yeah, thank you, Max. First, I'm Clément. I'm a distinguished engineer at Red Hat, working mostly around Quarkus, doing a lot of work with Max to give a direction and doing various things around Quarkus. Recently, we have been working a lot around the idea of working groups, which is a way for the community, so you to participate to the Quarkus development, to the Quarkus futures, and so on. We do have a nice, if you go to the Quarkus website, community, you have a working group page where you can see the running working group and so on. So that's mostly for the news, actually. But today we are going to talk about, as Mike said, one of the most boring topic in ITs, but very, very important, which is TLS. So Max, can you show my screen?
Yes, I will. There we go.
Yes, great. So on this screen, it's written two things, SSL and TLS. But let's be clear from the beginning. SSL is dead for more than 10 years. So rest in peace, long life TLS. And I'm going to talk about TLS. You will see that in our API, we still have method name SSL that we need to clean up. It's taking time. But yeah, we're not saying SSL anymore. It's TLS. So what does TLS mean? And I will start with a few slides before going to demos and showing what we did since April. So TLS is a transport layer security. It's the S in HTTPS, in Redis S, in AMQP-S. And if you want to explain TLS to your mom, it's a small lock you have inside your browser that makes sure that your bank is your bank. And why TLS is so important? It's because it encrypts the communication between the communicants, between the entities that want to discuss, like your web browser and the website of your bank, or any application. So as soon as you need security at the transport level, TLS is going to be your de facto choice. So what does TLS do? Three things. First one, as I said, is going to encrypt things. So it will hide the data between the different parties that are interacting, which means that once the communication is established, no one except the client and server will be able to read the data that goes through. Authentication, and that's actually very interesting too, it's you can be sure that the people you are talking to is actually what they claim to be. So, for example, if your bank is not a pirate bank that did some great CSS work to look exactly like your bank. So all this stuff with TLS, that can't work because you will see that the certificate says, no, doesn't look good. And integrity, it avoids messages and frame to be forged and tampered. And that's actually very important too, so you cannot have replay attacks and things like that. So one of the main issues with TLS is not what I just explained, is to use TLS, you need certificates and you need certificate management. And when you start discussing with an engineer or software developer about that, they say, no, that's a prod issue. We don't need to know this. It's going to be all managed by the infra. Well, yes and no. Basic understanding of what's going on is actually important. And if your server run plain text or TLS, the code path that gets used is very, very different. So it starts to be very important for you to actually look at run your application with TLS to be sure that it's working and not say, I'm running plain text locally and in test and prod will be TLS and everything will be fine. That's not really true. So
So Clement,
You-
just
yes.
could you give an example of this? Because one I know of, like we are very fond of not using mocks. So
Yep.
we test the REST endpoint. We actually want you to serialize the data through Jackson rotation to catch serialization issues. But for HBS, why do we care? Like, what are the examples of things that could go wrong if you haven't tested it?
Well, the code path you are going to use is very, very different. So what can you find? Well, maybe you will find that your TLS configuration is actually misconfigured, that your trust store is missing or contain badly signed certificates or things like this. Sometimes, for example, for gRPC, it's totally different between plain text, H2C, and HQ, which is TLS. So two different modes with very different behavior. One of the things, and I will explain why later, but typically if you are on the cloud and you do plain HTTP, after 10 seconds of activity, it gets cut because the front end want to recycle the connection. That does not happen with TLS. And there are reasons why. So there's plenty of things that behave slightly differently. And you need to be aware of this, and you need to test with HTTPS to be sure that everything is working fine, that when you interact with a remote service, that you have prepared the right configurations, that everything is fine, that you have designed things like, oh yeah, a certificate might need auto reload and things like that. But we are going to cover that in the demo.
It's not even slightly different. It's fundamentally different.
Yeah, it's fundamentally different.
It's not. It's like the difference between in process versus external serialization. Like it's two different. They from outside they do the same, but internally they're very different, and that's the same thing.
And if you do performance, it's very TLS has a cost, a big cost, both in memory but also in CPU, because there is a lot of encryption. Everything is encrypted, so you need to be sure that you plan enough CPU and enough memory, because there is a cost. Having a small lock inside your browser doesn't come for free. So when you want TLS, you need certificates, and here it can be problematic because you have two ways. Either it's issued by a trusted CA or trusted certificate authority, like Let's Encrypt. We will speak about that later. Or you self-sign. So you trust yourself and everything is fine. Funny thing is that certificates expires. So they have an expiration date. And this weekend, last week, Guillaume Smet, which is our main release manager, he pinged me and said, hey, we have a problem in this branch of Quarkus. We have a test that is not passing anymore. It was a 3.8 branch. It's not too old, but a little bit old. And I said, okay, I start looking at it over the weekend and found out that the certificate that we're using for testing, because we do have TLS test, expired. So, okay, fine. I need to regenerate the certificate. And here comes the wonderful world of OpenSSL. That command line is just a mess. So fortunately, in my case, I had this generate certificate.sh. I looked at it, it's 25 lines of OpenSSL invocation. I was like, okay, I can run that and everything will be fine. Well, actually, no, it didn't work. So basically, I had to drop this and use the new tooling we have to generate certificates. But yes, one of the first things is that you will need to learn how to generate certificates, and Quarkus is going to make this very, very easy. We will see this. Two things to understand. In a pure client server, the client has a trust store containing the certificates of the server, and the server has a key store containing that certificate, so the public faces, and a private key. The public faces is what we can name X509 format, contains the public keys, some metadata, common name, issuer, SAN, validity, and so on. We will see all this in detail. Let me switch this. So what happens when two entities want to interact using TLS? So first, the client, as I said, has a trust store, and the server has a key store. So the client will send a client hello frame saying, hey, I want to interact with you using TLS. Here are the set of ciphers that support the version of TLS I want, SNI, and so on. So the version of cipher is a collection of encryption algorithms that you can use. Version is SSL 1, 1.2, TLS 1.1, 1.2, 1.3. Please use 1.3, we're in 2024. And SNI is to select the right server and the right certificate and so on. The server on its side will get that request and send a frame back, say, okay, we are going to use this cipher, and that is going to be my X509 certificate, and send this to the client. Then the client must validate that the certificate sent by the server is actually the right one to get the small lock. So it will validate if it trusts it, if it's at the right host name, and so on. Once the validation is done and it's valid, it's encrypt a premaster. Well, it sends an encrypted premaster secret to the server then sends the session key, and after that point, it uses symmetric encryption. So both use the session key, and that session is that key is only valid for the session for the duration of the TLS connection, TCP connection. So for people in the security, it's kind of a Diffie-Hellman algorithm. So during the validation, it's where bad things can happen, because that's where you get SSL error and things like that. So there are a few things that are checked. The first one is validity, expiration. If a certificate expired, it failed. It say no, cannot establish SSL communication. Then you need to verify the signature, like the certificate is a certificate you trust. So we are going to look at the certificate, its issuer, and go through the chain until we find a trusted handshake. Trusted handshake being a trusted certificate from your trustor or from a certificate authority installed in your operating system. Then we verified if the certificate is not in a local list, which is a revocation list, a CRR. So typically, if a certificate got compromised, you can immediately add it to the list, so you are not going to trust it anymore. We have the hostname verifier. Lots of things have been written on this, but yeah, when using HTTPS, it's mandatory to verify that the certificate you get matches the host you interact with. As it depends on the protocol you use, it's pretty heterogeneous depending on the protocol.
And this is a thing that one area that makes all this stuff so complicated is all this stuff has changed over the years. Like host verification was not required until Java 8 or something, or 7.
Yeah, that's just the default.
Yeah, but it was in the middle of a release. Like it was like a update release, and that broke every Java app.
The world. Yeah,
the world. And and I think if people play with this, I think they probably bump into the biggest issue has not been, well, one is the management certificate, but the other one is just different behaviors at different times, different runtimes. So but we're getting better. So
okay, so verification very, very quickly is that when the server sends you a certificate, it does not send you one, it sends you a chain of certificates. It's certificate, the issuer certificate, and so on and so on. And you need to verify the chain, so verifying that they are all issued by the previous one until you find a trusted anchor, either a CA from your operating system or inside your trustor. So we are going to see this in detail during the demos. mTLS, mutual TLS, it's exactly the same, except that at some point here, I don't know if you see, you don't see my mouse, but basically, when the server sends a server hello frame, in addition to the chosen cipher and certificate, it'll also request a client certificate and expect the client to send its own certificate. That means that in terms of configuration, because that's what the impact you can see there, that the client won't only have a trustor, it will also have a key store storing its own certificate, and the server will have its key store, but also a trustor to validate client certificate. So basically, it's really mutual. So everybody check everybody. It's very useful, especially in the IoT world, because the client verifies that the server is the right one, but the server also verifies that the client is not rogue. It's not a rogue client that try to connect. That as soon as you have fleet management or things like that, very, very important.
Yeah, so it's a way to avoid, I guess, DDoS and avoid like unwanted traffic.
Exactly. What makes TLS even more complicated is that there is no one format say, hey, all your certificate will be in that. No. Everybody has designed his own format. So I will discuss three. PEM. PEM is a text-based. For each certificate, you will have two files, a certificate file and a private key file. So a trustor will be just a CRT file, but a key store will be a CRT file and a key file. You can have a potential list of CRT and keys and things like that. And there is no really extension, even if .crt and .key are the most widely used extension. It can be .pem, it can be almost anything. PKCS 12, unlike PEM, it's binary. It's password protected. So while PEM is just plain text, a PKCS is password protected. The extensions are relatively well defined, so it's P12, PFX, or PB12. Honestly, I never seen PB12 anywhere, but Wikipedia says that it existed, so we will consider that as a PKCS 12. It can contain multiple key and certificate in a single file and can have alias and things like this. PEM and PKCS 12 is what you should use today. GKS is a format that must die, in the sense that it was Java only. It's still there, but it's not the default anymore in Java, but it's still around, but heavily deprecated. So please consider other things. It's very similar to PKCS 12 in the sense that it's binary, password protected. Extension is .gks or .keystore, which can also be used for PEM, which makes things so cool. And yes, same thing. It has multiple keys and certificates. It can have aliases, but it's deprecated. All right, that's all for TLS itself. Let's look at the TLS, Quarkus TLS registry, which is a work we have been doing since April, I think. So first, I wrote an issue 3 years ago saying our TLS management is a nightmare. We need to centralize everything. We need to have things. Well, it took us 3 years to do it, but we made it. So still long open issue get resolved at some point eventually. And before that, before our work from April to today, each extension was defining its own TLS configuration, key store, trust store, and so on. And you can be sure that extension writers have been very, very creative in how they map TLS configuration. So not two extension, even extension I've wrote myself, but at different point of time didn't use the same TLS configuration. And each extension is managing the TLS connection, sometimes in some hazardous way, let's say, and most of the configuration were incomplete. I remember when I was starting doing that work, I had a one IT, which was gRPC, Kafka, and something else, where at that point, Kafka was only supporting P12, but gRPC only GKS, and another one only PEM. So I had three formats containing the same certificate. It was a nightmare. With the TLS registry, well, everything is in a single place. The configuration is complete, it's homogeneous, and everybody is referencing what's hosted in the centralized configuration. At runtime, it will manage the establishment, provide SSL context, vertex options, and so on, handle the reload of certificates, provide mechanism for doing this, provide a way for extensions to contribute certificates, provide a way for application writer or extension writer to reload certificates, an API to reload certificates, and so on. So it's much cleaner, and everything is a single place. So, for example, let's imagine you want to have the small lock inside your browsers. So what you will do, typically on the left side, you see an example with PEM file, where you say quarkus.tls, okay. Then we are configuring the default key store for my system, so it's good for my application, so it's just key store. Format is going to be PEM. 0 is because it's you can have name certificate here, because remember PEM you can have a list. And the cert file, the CRT file, the key key file, and so on. On the right side, on the top, you have the same configuration with a P12 this time, so it's pass and password. And as you can see, we use a format inside our properties because each format has its own set of attributes. And if we want IDEs to help you configuring things, we need to make that list now. So that's why it's done like this. Configuration can be name. If you don't want to configure the default one, you can just say, hey, Quarkus.tls, your name, and so on. And then all extension will use a TLS configuration name property to reference that name configuration. So typically here it will be HTTPS.
Yeah, and Clément, the one you had here is the new one, right?
Yeah, that's a new one. That's a new one. I didn't try to do the previous one. It's
yes, just for people to understand that this is the only if you just have the same like this key store for all your app. This is what you need to do. And before 3.13, 3.12, 11.12, you would have to configure it for gRPC, for HTTPS, for everything individually. Right? Now it's just one place. Yeah.
And there were other stuff like trustor was a build time thing. So if you say trustor at build times, then actually all your configuration was ignored because everything was trusted. Well, anyway.
Yeah.
Same thing for the REST client. Typically, for clients, you have to use a name configuration. You won't use the default one because it's confusing, especially when you use mTLS. So you need to have a name. Here it's my client. No, it's my TLS config here. And then you will point to the my TLS config here, trustor. So several clients can reference the same configuration. That's the important thing.
So do you have to, if you are using the REST client and serve out a REST endpoint, you have to configure both? Or?
Yes.
Okay.
Because you don't want the server to run with a trustor, because it can lead to security issues if you start doing this. So that's why we wanted to make things clearly identified to avoid those traps.
Got it.
Okay, time for demos because slides are great, but code is way, way better. I'm going to use that very complex application. We are going to see this for the rest of that session. So Quarkus REST, hello endpoint, all imperative, everything is fine. The only thing I do is I inject the HTTP server request here, so I can get some data about whether or not TLS is used and what certificate is used and so on. So as I said, some of our APIs need to evolve, but if request is SSL, then we print this, and get certificate will look inside the connection, get the SSL session, get the local certificate, just the first one, print the subject, issuer, expiration date, write a nice line, and that's it. Otherwise, it's plain text. Period. Nothing in configuration, all right? And nothing out of the ordinary in our configuration, like ARG, Unit5, and Quarkus REST. So that means that to use the TLS registry, so far it's not used because we don't have TLS, but you will see, you don't need to add a new extension. It's going to be automatically imported, this time by Quarkus REST, and so on. So let's run this application and see if it's working. All right, it's there. Okay, so it's working, and let's curl it to be sure. Curl HTTP 8080/hello, and we get hello plain text because obviously HTTPS is not enabled. We have nothing here. So what I'm going to do now is to actually generate on-site. I'm going to generate a certificate. And to do that, I will just ask Quarkus to do this. So Quarkus now this new Quarkus TLS command that can generate certificates. You don't need to know OpenSSL. And you give a name, you give the secret, because that's going to be P12 in that case, and you just say, hey, I want to be self-signed. I know it's bad, but it's for local. I just want to be self-signed. and this things over there is going to disappear. Right, Max? That's a bug I reported this morning. So now if I restart my application, and you see it has added the configuration automatically. So if I look here, I have insert, I have two new files, a local key store and a local trust store, and I have these configurations that got generated. It's only in dev because obviously using unsigned certificate in prod is something you need to explicitly do, not something that Quarkus wants you to do. So if now I'm starting this application again, it will use this configuration. All right, and now I should be able to use 443 like this. Okay, here. And you see that curl failed. Why? But it's very simple. I don't trust that certificate. Oh.
You have to be.
Oh, yeah, sorry. HTTPS. Here, you have the trusted issue like failed to verify the legitimacy of the server, which is what we want, but I can say, hey, I'm in local, so trust me. And then we see that we are running with TLS. The certificates are the subject, which is common name localhost. The issuer is common name localhost, self-signed, and the expiration date is in 1 year. Okay. Right. So first, to just start your application with TLS, you just need this one command. You're good to go. You can test and try your application all with TLS enabled. The dev console with all TLS, we are going to see this. But obviously now if I go there and I do HTTPS, let me copy that because I'm unable to write today. You see your connection is on private, which is not something we want because we want to try with, and it's annoying actually to have all this. So of course you can say, hey, I trust myself, I'll self-sign and so on. But Quarkus can help you doing this. Actually, Quarkus can, let me go there, installed a CA for you. I'm going to do here. So which is basically, yes. Let me delete this. Because that's the one I'm using. Yes. Okay. All right. Now it will reinstall one. So generate a CA certificate, certificate authority, and install it inside your system. To do that, it depends on your operating system. We support the 3 major one. It will obviously need your admin password. Okay. A few times. Okay, it's done. And now we have a Quarkus development CA that has been installed. And if you go to your keychain, so I'm on Mac, I'm not sure you can see it because I didn't find a way to zoom it. But you have it here. So it's your Quarkus dev root CA, but we will see this. So now if I go there and generate signed certificate,
yeah, because if the CA is not enough for the self-sign to be recognized, right?
No, because basically we need to regenerate one which is signed with the CA. The self-sign has been unsigned, or signed itself by itself. So here you need to redo it and say, hey, this time I want it to be signed. And it will look at the Quarkus CA, which is only valid for your laptop. It's not something that is widely on the cloud. No, it's only valid on your laptop and it's on purpose. So, and now we have a signed certificate. So if I do this, If I start my application, right, and now I can come back here. I don't need the dash key anymore because the certificate is part of my system CA, so I can go there and see that this time the issuer is no more localhost. It's universe world home Quarkus development for me. That's my username, and so on. And expires in 1 year, and so on. So this time it's valid, but the big advantage that inside your browser, you don't need to validate and trust anymore. It's going to be recognized, well, except on Firefox. Don't ask. Firefox do very weird thing in terms of certificate management. There is one more step to do. It's all documented. And if you go to the lock over there, you can see that the connection is secured, and you can see that, still can't zoom in here. No, yeah. That we have the right certificate issued to localhost, issued by Quarkus Dev root CA, and so on. That
So
also means,
yeah, go ahead.
yes,
No, go ahead.
that the Dev UI is behind HTTPS 2. So you, Dev UI, got trusted.
Yeah, so basically the issue we talked about before, like now any code you're executing is actually going through the full secured layers.
Exactly.
And you have all the serialization, all the security handle as you expect.
So typically here for the Dev UI, we have all the REST endpoint from this Dev UI that goes through HTTPS, the WebSocket for the logs, and everything else goes through HTTPS. So even the WebSocket gets secured. So yes, you run all your tests will use HTTPS there, and it's trusted on your system, so you can do whatever you want here. Relatively quickly, I'm going to show you the client too over there. So remember that Java is a little bit tricky in terms of keys or truster because it doesn't use the one from your system. And I'm working on that, but it's not completely done yet. So I'm going to show you where I am right now. So here is my REST client. Okay, it will call the hello method. That is a method printing things. And I have a client resource, which is just calling it. So very, very simple. Now here, I have several choices. So if I could use that configuration over there, which will say, okay, I need a truster that contains the certificate of the TLS service that I just ran, containing the actual certificate. So if you are using self-sign, it's what you are going to do. Here, because I'm using a globally signed one, well, using the Quarkus CA, I can actually just say, hey, load the Quarkus CA one and be done with that. And these 2 lines here will be automated very, very soon. I'm working on that. I was hoping to finish it this morning, but got stuck in meetings. So, but it will be there. So now if I go there, where is my client? I go there. That means that for the client, you don't have to copy any certificates or any truster. You just refer on the truster, the CA, the Quarkus CA, and you're good. In the sense that, yeah, it's fine because all the certificates you are going to issue then are signed by this one. So now if I go there and it's on port 8082. Oops. Here. You see that it receives hello with the right certificates that is trusted and so on. If I remove these lines, well, actually, if I remove just this, you will get an error because it gets an HTTPS but can't validate the certificate. So here, because it's Java and Java use their own things, you still need to validate to do this, but soon it's going to be automated. So now if I would do this,
but just be, because this is So what you're going to add is that if you don't specify a path, you will go look in the Quarkus directory for that one and pick it up. And if it's not there,
I'm going to locate the Quarkus CA and say, hey, you have a Quarkus CA, I'm going to use this.
So that's what Benjamin here is. There's a question here. It says, Benjamin Ramondi says, hello, what happens if I get in root CA twice? Same root CA will be shared with all my apps.
So it won't renew. Well, depend if you use -- renew or not. If you don't pass the renew parameters, it will say, hey, you already have one. It's not expired. Keep it. If you pass -- renew, it will regenerate one. And then you will have to regenerate all your signed certificate. Unfortunately, there is no other way than doing this. If you don't pass renew, but the CA has expired, so in 1 year, it will renew it automatically.
Okay.
Yeah, all your app locally run on the same CA. That's the overall idea.
Yeah, that's the default, right? But
yes.
Eventually, if you want to, you can write 2 apps that use completely different.
Oh yeah, sure, yeah. That would be very similar to the self-signed one, except that you will have 2 CA. Yeah, no problem.
Yeah. So, very nice.
All right, so that was for development and so on. So now we are going to do some other stuff, and I'm going to go in same application, but the deployment is slightly different. Same application, but this time I want to use PEM file, and I want to have PEM files located in the third directory. So what I do here is that I have a third directory. I'm going to make sure that actually that they use these certificates here, the CRT file and key file. So you have a CRT file here, you have a key file here. As I said, it's PEM file, so you can easily open it. It's text and so on. Now I'm going to run that application. Right. So it runs on port 80. Yeah, so same port. So I don't use a CA in that case, so that's why. And you see that the expiration date is going to be the 21st of September. Now what we can do, so that's how you configure your system basically in production. Now I also added this, which means that every 30 seconds is going to check if there is a change in this certificate. And if there is a change in this certificate, it's going to roll out the certificate without restarting the application. Because right now I'm in prod, and it's not dev mode this time. So now I just update certificate. We are going to wait a little bit. Oh, I've seen it already? Okay. Yes. And this time it used a new certificate that I copied at the right place, and it's 2025, 18th of June. I have no idea how I computed these dates, but yeah. As you can see in the log, it's written that it has updated the certificate, and you may wonder why it has said it multiple times. Actually, Max, do you know why it's write it multiple times? It's not a bug.
Multiple systems.
Multiple times the same log here.
Yeah, I'm assuming. Well, it's the same. I know each layer asking, and then there's different each thread or each
event loops is actually asking and get reloaded. So if you have so we create many HTTP server to handle the load more properly. So one per event loop. And each HTTP server gets the new certificate. So you get the log as many times as HTTP server you have. Established connection won't see the new certificate until they reconnect. So that means that for in-flight request, there is absolutely no descriptions. Everything is fine. And then when they reconnect, we get the new certificates. without any disruption. This has let us handle things like the Kubernetes cert manager. Everything is documented, or you can use the certificate cert manager, and the OpenShift variant of the cert manager, which I prefer personally. I found it a slightly higher level. Both are using this mechanism. But you can say, hey, but great, but sometimes it's not what you want. You don't want periodic reloading. You actually want something which is way more flexible based on event and so on. It's not a problem because we have delivered an API where you can pick a certificate from the registry and ask reload when you believe it's the right time to reload. If there is a change, the change will be applied. If there is no change, he will just say, hey, sorry, no change. And of course, it works with native. I just saw the message, so sorry. So yes, all this works with native completely. So for example, this reloader APIs, imagine you are using Vault, and Vault store your certificates. So first, the Vault extension can register the certificate in the TLS registry, and you can reference them. That will work. But if Vault is sealed, or if one of the certificates got compromised for whatever reason, you get an event and you can say, oh, I want to reload right now because we need to change something. And that will happen immediately. So you don't necessarily need to have a reload period. You can just have your own way to do the reloading as you want. There is so many different ways or when you want to reload that we cannot cover everything. We provide that periodic one. That's a simple one. If you want your own, you can write your own. It's a couple of lines of code. It's just an SPI to implement.
And maybe this, because this is one of the things I always, well, when I heard about it, surprised me, is that there are systems where they renew the certificates every like few minutes, even between internal service and a community's deployment, simply to avoid any, or sorry, not avoid, reduce the chance of middle attacks. So yeah.
Here I said 30 seconds. I didn't know when I was running the demo, but yeah, you can be. Well, this will be way too much. Typically, that will introduce way too many RAID to the file system. So 30 seconds looks okay-ish, but yeah, will depend on the system. Or if you get an event, an external event, write your own things, wait for the event, call the reload method, you're done.
And before you did this, your Quarkus app basically had to restart, right?
Yes.
Yeah. So, but of course, it's not an event in Quarkus land, but if it's every 3 minutes, then it's probably a problem.
Yeah, that's the problem. Is using a mesh that is well, if you're using a mesh, it generates a proxy. But imagine that you're interacting with something that renews the certificate very, very quickly. Restarting every minute is a no-go. So yeah. So now let's see if the final demo is going to work. No. Not. Yes. Yes. Okay, I have an EC2 instance running EU West. So I don't know why it is, but it's in Europe, which for me makes a lot of sense. I choose Amazon Linux, but use whatever you want. I have my application, which is deployed here. Oops. Yeah, so it's app lib, well, regular things. I've added a config, which only contains a port. So I want to open on the 43 port, the 80 port, and things like that. So no more. I want to be exposed directly on the internet. Right now, my application is not running. If I do this, it's not running. This is just GPS itself. So I want to, I just want to see. Yes, that's right. I want to negotiate a certificate with Let's Encrypt. Imagine this, because I want a trusted certificate. Well, I'm going to use Let's Encrypt staging, so it's not going to be trusted because it's just for demo, but basically that's what will happen. Well, we have added a way to do that. So when your application is not running, you are going to use Quarkus TLS Let's Encrypt and prepare, and you pass your domain name. Remember that you need to configure the domain name to point to this EC2 instance. Huh? Otherwise, it's not going to work. But yes, so you do this. And yes, okay. So, and now it's going to prepare everything for your application to handle the challenge for Let's Encrypt to deliver a right certificate. So what did it do? It created a Let's Encrypt certificate with a self-signed CRT file and key file, because it need to be, the first interaction need to be secured, otherwise you can have attacks. But this time it's self-signed, and it's okay for Let's Encrypt because I trust everything in that case. And we also have some more configuration here, which is, well, we point to the certificate that we just generated. One of the things I forgot to mention that is my application actually, no, so there is, where did I generate that? So there is a Let's Encrypt flag to enable when you build your application, which is a build time thing. And now that we have this state, I'm going to start my application. So let me go to my just file here. And definitely don't do like me. Use systemd or whatever. Don't do sudo and so on. But it's just for demo purpose, it's fine. Huh? Otherwise, you are not allowed to expose the port for 80 and 8083. So now, if I go back here and I do curl command, so if I'm using plain HTTP, it's working. It's my application. And if I use HTTPS, well, I will have that error because it's a self-signed certificate. Well, even at the end, it's but yeah. But the issuer is me. So you see that it's not a valid certificate. It's just to prepare the things to happen. Once the application is running like that, you keep it running. And one of the things which is important is that the management port is actually enabled. I don't know if you see it here, but I have the 9000 port, which is not exposed on Amazon. So this is not reachable from internet. So now I'm going to ask Let's Encrypt to generate a certificate. So I have a longer command here, which is named issue certificate. You need to pass the domain again. The management URL where I'm going to post the certificate once I get it, and my email address because they need to associate that. Because I don't want to use valid certificates, I'm just to say, hey, use the Let's Encrypt staging. Sure, it's not going to be a trusted certificate, but that's for demo purpose. And yeah, it's just I'm going to delete the instance in a few hours, so that's fine. So if I do that, it's going to interact with Let's Encrypt. Yes. And configure the challenge inside this application. This application over there is actually going to handle the challenge. Let's Encrypt is going to validate that. So it's what he's doing right now. And that's it. The management challenge endpoint. So Let's Encrypt has validated my challenge. We remove the challenge from the application using, again, the management API. And then we say, hey, we have the new certificate. Go and reload them. So now immediately, I don't have to wait 30 seconds and so on. It's one of the custom reloader. We have a new certificate from Let's Encrypt. Wannabe Watercress. I have no idea what version is it, but it's the staging server. And that's it. You don't have to install another tools or look at how we do things. Just follow the instruction, prepare the application, use the command, boom, it manages the Let's Encrypt validation or challenge. Get the certificate, install it. You want to renew? We have the same, but instead of issue certificate, it's renew certificate, and it will do exactly the same thing. It's actually very similar in terms of process. And voila, that was my last demo. So we have seen how to configure the new TLS with the new TLS registry locally with signed certificate, or to generate signed certificate without having to use OpenSSL. We have seen how you can use a CA installed on your operating systems to make things a little bit easier, not having the infamous red screen inside your browsers to trust things and curls, trust things, and so on. We have looked at the client side. How do you configure the client side? I use REST client, but that's exactly the same for all the clients: gRPC, Redis, reactive messaging, so Kafka, Pulsar, Rabbit, MQP, MQTT, all use this already. It's WebSockets. They're all using that new mechanism. The previous one is still supported. No worries, we didn't break. We just recommend you to switch to this. I've shown how to use PEM files in production, how to do the reloading in production automatically. And then we finish with the Let's Encrypt feature, which is the one the last one we added, where we interact with the Let's Encrypt. You don't have to do anything, just run the command, you're done. The only thing you need is having a domain name. That we can't do. We can provide that for you. At least not yet. Well, but yeah, that's all. And yeah, this is actually really running on Amazon. Now you see the thing.
Yeah, it's basically two things, right? One, simple, like super simplified configuration and reloadability of your certificates. I think it's the well, let's say biggest one, but it's the main cleanup compared to older ones. And then there's this thing what you shown here with Let's Encrypt and the local generation that you can run easily, fully certified, both locally and in a production environment, without having to run complicated certificate managers and other stuff. Right? So that is very cool.
I forgot to mention one thing, is that we also have released JUnit 5 extension for your test, where you can generate certificates for your test. So you don't have to generate them, store them on your file system on Git or whatever, but always having fresh one for your test. So at least it will never expire, which is good. They're all self-signed, but it generates also the trust store, and you can just do such kind of things, and it will generate the certificates.
But how is that then picked? Then you
will have to configure it with that right now. It's something I want to discuss with Georgios. Is how Georgios did the first step, how to make rest assured pick them automatically. We need to continue.
And I guess you don't want to run these in parallel.
Oh well, if you use different names,
then it could.
It's fine. If you use the same names, no. No.
So
yeah.
Cool. Very cool.
We also have a Maven plugin. If you want to run them in parallel, you generate them inside the Maven plugin phase, and then you can run your test in parallel.
So if anyone wants to, because you present a lot of information here, what's the best place to go look? Is that the TLS registry references, or is there a guide, or?
TLS registry reference Quarkus. You should get to this page here. Picking main to have the latest one. So TLS registry reference. We have our docs team, which is doing some edits right now to make it even better. It's the first edits I do make really a big difference. And you can check how to configure TLS, the registry API to find configuration at runtime, registering a certificate from an extension if you're an extension writer. I mentioned, one thing that was not done yet before, but we're now doing, is that at startup, when it's configured, I'm going to check that everything is valid. So it had a bit of startup time, but it's better to fail at startup saying your certificate is wrong than getting a cryptic SSL error in production. The reloading certificates, the API, I mentioned it. How to do to update the API? Well, that's very simple. You just do. You get the TLS configuration with a given name, or you configure it, and you just fire the certificate reload event. Boom, voila. Kubernetes secrets or cert manager, the OpenShift variant. Why do they have a variant? I don't know. Everything about the local thing, the local CA. You have all the commands. Everything is documented here. Yeah, and the Let's Encrypt one.
Very cool.
Which is exactly what I did, just with a lot more text. Oh, and you don't have to use EC2 instances actually to test Let's Encrypt. Sergey came with a very nice way to use ngrok from your machine to verify that the Let's Encrypt protocol works and things like that. So you can check that, and if you are using ngrok, go ahead. You can use ngrok from your local machine and get a Let's Encrypt certificate. The questions that I generally have is, why didn't I use Let's Encrypt for the local one? Because Let's Encrypt explicitly says that it should not be used for localhost. So I don't want to abuse their resources. So I came with my own CA.
Cool. Yeah, I think you can use the local host, but they don't want you to, right?
Yes, they don't want you to, but yeah, I have been a nice citizen here.
That works. Very cool. Well, I think that leaves us to the end. So
yeah, and
yeah, no, I think this has been a long-awaited cleanup, and we get all these edited features is awesome. So very cool. Cool. Well, then see you next week. And
yeah, I don't know who is talking next week.
I don't know nothing.
That's someone.